Alright, we're going to simplify these expressions, and I'm going to use the properties given earlier to simplify the understanding of how these are solved. Okay, first I'm going to expand this into 6 times 6. 6 times 6 simplifies down to 36. For this one right here, I'm going to first convert this negative into a negative 1, and we have negative 1 times 6 squared. Then I'm going to expand the 6 here under the square. We'll get negative 1 times 6 times 6. Okay, now when you multiply this negative times two positives, we get negative 36. It makes more sense why the answer is what it is when we use all the properties and steps. Number 3. We have a negative here. We're going to remove that by taking the reciprocal of the base. We'll get 1/6 as the reciprocal to the second power. And now we will expand this into 1/6 times 1/6. 1 times 1 is 1 for the numerator. 6 times 6 is 36 for the denominator. And it makes sense why it's 1/36 using the properties. Number 4, we have a negative here and here. We're going to deal with the negative here by converting that to a negative 1. So this will be negative 1 times 6 to the negative second power. Next, we're going to deal with this negative right here by taking the reciprocal of the base here, which is 6. So this becomes negative 1 and a 1/6 to the positive second power. Thirdly, we're going to get rid of the 2 by expanding this into negative 1 times 1/6 times 1/6. And when you multiply negative 1 times 1/6 times a 1/6, it makes more sense why we get a negative 1/36 for negative 6 raised to the negative second power. Number 5. Here, the negative is within the parentheses. Parentheses keeps us from reaching something so that we can work with things on the outside. So we can't work with the inside, so we'll work with the negative on the outside. When I remove this negative, we take the reciprocal of the base, the parentheses remain, and we get a negative 1/6 inside. And again, the parentheses are still there, so we can't do anything to the inside, so I'm going to expand this into negative 1/6 times negative 1/6. And now I can multiply these. A negative times a negative is positive, 1 times 1 is 1, and 6 times 6 is 36. Okay, finally, number 6. We have lots of negatives here, here, and there. Let's deal with the negative on the outside. The negative on the outside can be converted into a negative 1. We can't bother with the negative inside because it's held within the parentheses or protected by the parentheses. But we can take this negative right here and take the reciprocal of the base. So what we'll get is a negative 1/6 all to the second power. And again, the negative inside is still protected, so I'm going to expand this using the 2 here. So we get negative 1 times negative 1/6 times negative 1/6. And when I multiply a negative 1 times a negative 1/6 times a negative 1/6, I get negative 1/36. And the answer makes more sense. Again, the more steps that we use, the more procedures or the more properties that we use. Number 6, we're going to simplify this. So first I'm going to start by factoring the 48, see if I can find any perfect fourths. So we get 2 times 24. 24 gives us 2 times 12. 12 gives us 2 times 6. And 6 gives us 2 times 3. This will give me 2 to the 4th here. So 2 to the 4th is a perfect square. Or should I say 16 is a perfect square. So we have the 4th root of the 16 times the 3 here. The 16 represents the perfect square. That's a perfect root. The perfect 4th root of 2 times 2 times 2 times 2. And x to the 5th, that's not within the 4 time table, so we're going to expand that into x to the 4th times x. 16 is in the 4 time table, so this is a perfect 4th. So we're going to keep y to the 16. Z to the 21st power is not a perfect 4th root because this is not the 4 time table, so I'm going to expand this into z to the 20th times z. Or should I say z to the 1st. Okay, the 16 will come out, because it's a perfect 4th, as a single 2. The x to the 4th will come out as a single x. The y to the 16th will come out as a y to the 4th. And the z to the 20th will come out as a z to the 5th. So what we have is a 2x, y to the 4th, z to the 5th power, and within the root, we still have the 3, the x, and the z. 3 times x times z remains unsimplified within the root.